How do singly, doubly, and circular linked lists compare? Imagine organizing a collection of items where each piece points to the next, creating a chain that can be navigated in various ways. This concept forms the foundation of linked lists, a fundamental data structure in computer science. Understanding the differences among singly, doubly, and circular linked lists can help clarify how they function and where they are most effectively applied. A singly linked list consists of nodes where each node contains data and a reference to the next node in the sequence. The first node is called the head, and the last node points to a null value, indicating the end of the list. Traversal begins at the head and continues through each node until reaching the null value. Singly linked lists are simple to implement and requiring less memory per node because they store only one reference. However, they are limited in navigation because moving backwards or accessing previous nodes is not directly possible without starting from the head again. Doubly linked lists extend this concept by adding a second reference in each node that points to the previous node. This bidirectional linking allows traversal in both forward and backward directions. As a result, operations such as insertion and deletion become more flexible, especially when working with nodes in the middle of the list. The trade-off is increased memory usage since each node must store two references, and the implementation is slightly more complex due to maintaining two pointers during updates. Circular linked lists connect the last node back to the first node, forming a loop. In singly circular linked lists, the last node's next reference points back to the head, enabling continuous traversal without encountering a null value. This structure is particularly useful in applications requiring cyclic processes, such as round-robin scheduling or buffering systems. Circular doubly linked lists combine the advantages of bidirectional traversal with the looped structure, allowing movement in both directions around the circle. This setup is beneficial in scenarios where navigation needs to be flexible and continuous, such as in certain types of caches or playlists. In summary, singly linked lists are straightforward and memory-efficient but limited in navigation. Doubly linked lists offer enhanced flexibility at the cost of additional memory and complexity. Circular linked lists facilitate continuous traversal, making them ideal for cyclic processes, with circular doubly linked lists providing the most versatile navigation options. Each type has specific strengths that make it suitable for different programming challenges and system designs.